We're on the front end of projects. Once they're ultimately approved, then that's when the transmission line engineering team, my team, takes over and has the responsibility of performing the design work, specifying the materials, and creating the construction plans. We have standards for loading criteria. That way we're not only meeting just the minimum, we're also meeting the type of weather events that we'll see in our service territory. Long-term transmission planning does studies and evaluates what needs to be upgraded. Essentially the ampacity rating of the line. SPP also does those studies. So it's not just coming from internal groups, it's coming external as well. And most of our materials we've transitioned to material that will last longer, it's more reliable, requires less maintenance. So yeah, predominantly we are installing steel in place of wood now, but not all the time. I mean, there are applications where wood's still used. We go out and get what's called LiDAR surveys. It's an aerial based survey. We get that for the ground and our structures and the wire, the terrain, and to understand what obstacles we have to design around. So, we're getting a three-dimensional view it's identical to what's out in the field. You do need to get out in the field, or we need to get out in the field to see that kind of broader picture, right? I mean, we're looking at a very narrow corridor and things can be missed from time to time. So we do get out in the field.
So right now we are southwest of Jeffrey Energy Center by Paxico, and this is the Jeffrey to Morris 345. They come through here every 10-ish years. They check ground line and then they do a visual inspection. So when they check the ground line, they'll pull a core on that pole, they'll dig around it, and it will show how much longevity that pole has left. When they come through, if we're on a 10-year cycle, we try to change everything out that we predict will fail in the next 10 years. A wood pole over time, it'll shrink up. The treatment comes out of them. You're always fighting loose hardware. When wood breaks, basically it snaps and it'll shock load the next structure and the next structure. So you kind of get a domino effect. You can still have that with steel, but that steel's gonna bend and then it's gonna break, or like when we use a steel arm, it's not just gonna snap, it's gonna try to fold forward. So it's gonna slow that shock down. There'll be a steel structure within every mile to half mile between Morris and Jeffrey. Over time, the cost difference between wood and steel is kind of, there's still some difference, but it's got closer. So you're gonna get more years out of that steel arm, and you're gonna get more years out of the steel pole, and you're gonna be able to predict how long it's gonna last better than with a wood. You're gonna get a longer lifespan. We're gonna get more bang for our buck with this steel structure than we would a wood. When Craig asked me about it, I was like, I told you last time I had a face for radio.
That's right, you did.